Bismillahirrahmanirrahim. Sallallahu alayhi wa alihi wa sallam. Allahumma rabbi zidni ilma. Sallallahu alayhi wa alihi wa sallam. Ameen. Alhamdulillahi rabbil alameen. In this lecture, I will discuss some important concepts of partial fractions. For this lecture, I am using the work of one of my best student, Miss Vania Jabin of class 2024, the Lyceum. An important advice: do good by everyone. Partial fractions. Partial fractions means to split a single algebraic fraction into two or more fractions. In O levels, we learned how to add and subtract algebraic fractions. For example, express this as a single fraction. So by taking the LCM, we can express these two fractions as a single fraction. And the reverse of this process is known as partial fraction. In partial fraction, we split a single algebraic fraction into two or more fractions. Applications of partial fractions. Partial fraction is used to expand binomial expansions where n is not positive integer. N could be anything except positive integer and 0. N could be negative integers and rational numbers. The second application, partial fraction is used to integrate rational expressions such as 2x minus 1 upon this by first splitting the expression in partial fraction. First we split this fraction in partial fraction and then we integrate it. Note, while solving questions of partial fractions, first distinguish between the following three things. Number 1, types of fractions. Number 2, complete factorization of the denominator. Number 3, types of factors. Number 1, types of fractions. There are two types of fractions, proper and improper. So, proper fractions. In proper fractions, the highest power of the variable in denominator is always greater than the highest power of variable in numerator. See, in this example, when we will multiply these 2x, we will get 2x square. The highest power of variable in denominator is 2, whereas the highest power of variable in numerator is 1. So when the highest power of variable in denominator is greater than the highest power of variable in numerator, then the fraction is proper. So this fraction is a proper fraction. See this example. The highest power of variable in denominator. Well, when we will expand this, we will get 9x square. And when we will multiply this x with this, we will get 9x cube. So the highest power of variable in denominator is 3, whereas the highest power of variable in numerator is 2. So 3 is greater than 2. Therefore, this fraction is proper. Improper fractions. Well, in improper fractions, the highest power of the variable in numerator is either greater or equal the highest power of variable in denominator. But in P3, the greater power is not in this syllabus. So for improper fractions, only equal powers are in the syllabus. So in this example, the highest power of variable in numerator is 3 and the highest power of variable in denominator is also 3. So when powers are same, then the fraction is improper. So this fraction is an improper fraction. This is the example question. See, when we will multiply these two terms, we will get 2x square. And here the highest power is 2. So in numerator, the highest power is 2 and in denominator is 2. So this fraction is improper. Now the second thing, Before solving questions of partial fraction, we need to observe the denominator. The denominator of the fraction must be in its simplified form. So first observe this fraction, type of fraction. See, the highest power of variable is 3 and the highest power of variable is 2. So this fraction is proper. Now the second thing is, observe the denominator carefully. This is the simplified form, but this can be simplified. So you have to factorize this factor. So when you will factorize this, you will get x minus 1, x plus 1. You will get this result. So this is the simplified form of the denominator. So if denominator is not in its simplified form, then get its simplified form by factorizing the denominator. Now, second example. See the fraction. The highest power is 3 in denominator, whereas the highest power is 2 in numerator. So this fraction is proper. Now observe the denominator. This is fine, but this can be factorized. When you will factorize this, you will get x minus 3 whole square. So this is the simplified form of the denominator of the fraction. So we have done two things. Number one, types of fractions, and number two, denominator, simplified form of denominator. Number three, types of factors. There are three types of factors in P3 syllabus. Number one, linear factor. Well, this is the generalized form of linear factor, ax plus b. Why? Because the power of variable is 1 and the power of expansion is also 1. So this is the generalized form. Now examples. For example, 5x plus 1. You can also write this as 5x plus 1 bracket, because this has power 1. This is also a linear factor. This one is also a linear factor, x. This can be factorized. So this can be factorized into two linear factors. This factor is not quadratic, because this can be factorized. When a quadratic factor can be factorized, then the factor is not quadratic. What if we had x square plus 9? Then this cannot be factorized. So this is not a linear factor. So this is a quadratic factor. We will discuss this later in this lecture. So when a factor is factorized, you have to factorize it. We have got two linear factors. This can also factorize x minus 3, x minus 2. So these are the examples of linear factors. And this is the generalized form of linear factor. Number two, repeated linear factors. Well, linear factor means, this means ax plus b, because power of variable is 1. And repeated means the power of expansion must be 2. So this is the generalized form of a repeated linear factor. This is here. Now if you square these factors, then all these factors will become repeated linear. See, 5x plus 1 whole square, repeated linear because power of expansion is 1, power of variable is 1 and power of expansion is 2. Here power of variable is 1 and power of expansion is 2. So repeated linear. This is also a repeated linear factor. You have to check this, factorize this. So this is a repeated linear factor. So these are the examples of repeated linear factors. Next, quadratic factor. Quadratic factor means that cannot be factorized. So this is the generalized form, ax square plus b. We must have only two terms with power of x2 and there is a plus sign. Constant, variable, x square and plus sign. So factors of these types are known as quadratic factor because these factors cannot be factorized. These are the examples. We cannot factorize these factors. So all these factors are quadratic factors. Rules for fractions. Well, I will discuss this in my next lecture, inshallah. Good luck and Allah Hafiz.